magnetic field due to a long straight current carrying wire. We have to find out the magnetic field at any point P. This is a long current carrying wire. Consider a small element dl. From the point P, draw a perpendicular onto the wire and let that distance be capital R. Draw or join the point P to the center of the element of length dl considered and let that distance be smaller. Let this angle be pi minus theta and let this angle be alpha. We have to find out the value of dB at this point P due to the small element dl, and then we will integrate that for the entire wire. So the first point is, in the derivation, applying Biot-Savart law at this point, we will get dB equal to mu 0 by 4 pi I dl sin theta by r square. Call that equation 1. Now how do we get B? Integration of dB, it is equal to mu 0 I by 4 pi integral minus infinity to plus infinity sin theta dl by r square. I is a constant, so it has come out. Now small r, referring to the figure again, Pythagoras theorem, it will be root of L square plus capital R square. Sin theta is sine of pi minus theta, and from the figure sine of pi minus theta, opposite side by hypotenuse, and that is equal to R, capital R by small r. Substituting value of small r, we get this value of sin theta. Now substituting the value of r and sin theta in the expression for B, we have mu 0 I by 4 pi integral minus infinity to plus infinity r dl by L square plus r square to the power 3 by 2. Now L can be written as r tan alpha. Since dl is required in the expression, dl is equal to r secant square, because derivative of tan alpha is secant square alpha d alpha. Substituting these values and changing the limits, mu 0 I by 4 pi minus pi by 2 to plus pi by 2. When you substitute the values, you get this, and it is simplified in this way. So you have mu 0 I by 4 pi minus pi by 2 to plus pi by 2 d alpha by r secant alpha. Taking the secant alpha to the numerator, it becomes cos alpha. Integration of cos alpha is sin alpha between the limits. When you apply the limits, you get 1 plus 1, 2. Cancelling that with 4, you have B equal to mu 0 I by 2 pi r. So mu 0 I by 2 pi r Webers per meter square, or Tesla, is the formula to find out magnetic induction due to a straight current carrying wire, where I is the current flowing through the wire and r is the distance at which point you want to find out. Distance of the point where you want to find out magnetic induction from the current carrying wire. Now, so this is, if you have a current carrying wire, this is the direction of the magnetic induction, this is the direction of the current flowing through the wire.